Hey guys, I thought it'd be cool to show you what I've been working on for the past couple weeks. So I've written a program that allows you to take a user input, in this case an Xbox 360 controller, and it sends off analog values for when you go up or down with the joysticks using a protocol. It sends data packets off to the microcontroller using USART. It then is sending information, to be precise, a PWM, a pulse width modulation, to these LEDs that tells it to turn on and off. So what these LEDs are the green one, so you'll see them in two pairs. So the first pair, what they represent, the first one is the green one is the PWM signal, and the white one is me going in reverse. So as I go up on this joystick, you'll see a light go on, the green light ramp up for as much as I go forward on this. And then as soon as I reverse on the joystick, you'll see this start to ramp down. But as soon as it ramped down, it will start to ramp back up, but this light, the other light, will be on. And all of these lights, all these pairs represent all the other analog values that I can control with this Xbox 360 controller. So the goal of this is not to just control lights, but I want to be able to send off this pulse width modulation to ultimately be able to control a thruster, shown here. And of course this microcontroller does not supply enough voltage to power this thing. So instead of sending the PWM to an LED, I am instead sending it to an amplifier. And this guy is powered by this 24 volt Stark Power battery. It's 10 amp hour. And this will control the thruster. So what I'm going to do now is I'm going to show you different variations of duty cycles based on how far I push this joystick up. And let's plug it in. So it's going to be a little hard for me to show you everything that's happening. So let me first show you the interface that I created on here. So as I go up with the joystick, you can see the axis increasing. I've rigged this to show the duty cycle of what it's emitting, and if you can hear in the background, you can hear the thruster. And just for safety reasons, I only put it up to 70%. I don't want to go full 100% on these thrusters because they're meant for underwater and they would overheat if I was at 100% for a long time. So let's go over here to the thruster as I slowly increase the joystick. And then in reverse. We've also I've programmed the joystick to automatically ramp down if you go fast backwards, because if there's a big jerk and if it's in other systems, more the sensitive components would have EMI. So if I go reverse like that, it slowly ramps down and goes back in reverse. And in the background, I set up an oscilloscope that shows you the duty cycle. So if I ramp forward, you can see it slowly ramping up. Notice there's no jerk. And then I go in reverse fast, and you can see it ramp down slow. and you can see the number in the background right there. That is the actual pulse width modulation. That is the voltage that I'm emitting out of the microcontroller. And I know that my maximum the joystick maximum placement that I can go up is 70% duty cycle, and I know that the microcontroller is emitting 3 volts. So you take 3 volts and you times it by 0.7 right here, and that should show around 2 volts, and it does. So we know that when the joystick goes up and I'm receiving the signal right here, this is right around the max. The reason why it's not exactly 2.1 volts is because there's always going to be some slight deviation for error. And also, if you see the other LEDs, again, I just have one thruster hooked up. But if I had multiple amplifiers and the proper connectors, I would have all of them set up. But you can see the other LEDs react based on the controls that I use here. So you can use these and so on. Thank you guys for watching.